In this video, we're going to plot some polynomial functions. Now, this is a lot easier and takes a lot less time than you might think, even if the polynomials are really complex. So, okay, let's start. Let's go ahead and plot the polynomial shown here. So the first thing we want to do is fully factor the expression. So let's take out an x squared, and we're left with x minus 5. Okay, so we're going to have this shows us that we'll have an x-intercept at 5 and at 0, and it also shows us that the multiplicity of the x-intercept at 5 is going to be 1, and of the 0 x-intercept it's going to be 2. Okay, now we can see that if we plug in x is equal to 0, we see the y-intercept is going to be 0. A polynomial is only going to have one y-intercept, so it's at 0. Okay, now we also want to check if the function has any symmetry. So let's see, to do that, just plug in minus x for x. So you've got minus x cubed minus 5x squared. We could take out a minus. What does that give us? Okay, so this is not equal, f of minus x is not equal to the original function, but it's also not equal to minus f of x. This is close, but it's not quite minus f of x. Minus f of x is minus x cubed plus 5x squared. This is minus x cubed minus 5x squared. So, okay, and then no polynomial is periodic, so there's no symmetry here. All right, now we want to analyze the end behavior. So as x approaches infinity, the function does what? Well, okay, like we showed in the previous example problem videos, we worked a bunch of problems to analyze the end behavior of a polynomial. You look at the leading term only and ignore the other terms. So x cubed, it's got a positive coefficient out front. It's odd power, so as x goes to infinity, f of x goes to positive infinity, and as x goes to negative infinity, f of x goes to negative infinity. Okay, so now we can go ahead and let's plot everything we have here. We've got the y-intercept and the x-intercept at the origin, and then we'll say let's do 10 minus 10. Okay, so that's each tick mark then is 1/2, so 1, 2, 3, 4, 5. Okay. Okay, so now here technically we have enough information to plot the polynomial. And if we do, we'll get the general shape. And some people actually do, you'll see examples, people will plot polynomials with just stopping here. So in other words, what you can do is you come to the farthest x-intercept to the right, and then you see, okay, its multiplicity is odd, so we're going to be crossing through the x-axis. And then as x goes to infinity, is it going to positive or negative infinity? It's going to positive infinity, so you just kind of do this. Okay, now we know we're going to have a turning point in this region because we need to come back to the x-axis to get to the origin. So and then we're going to be, this x-intercept is even multiplicity, so this will be a touch point, so we can do like that. And then as x goes to negative infinity, the function goes to negative infinity. There's no more x-intercepts or anything, so we just like that. And this is, you know, this is correct. This gives you the general shape of the polynomial graph for sure. We see we've got one turning point, but an even multiplicity x-intercept, you don't consider that a turning point. So we've got one turning point. We see the turning point. We see where it is. We see the x-intercepts. We see the end behavior. So this is correct. However, if you want to refine the shape and, you know, just kind of dial it in a little bit more, you can plot some additional points just to help guide you. So that's what we're going to do. Okay, so we can So one way you can go about this is you can just plug in the easiest points. You could just plug in some easy points. So like, for example, f of 1 is 1 minus 5 is minus 4. F of minus 1 is minus 1 minus 5 is minus 6. That's easy. So I would say do that, but then also what will make it, what will be helpful is to plug in. So you plug in 1 point to the right, all the way to the right, past all the x-intercepts, 1 point all the way to the left, past all the x-intercepts, and then 1 point in the middle of each x-intercept, because that point will give you a sense for how far the turning point goes. I want to say the middle point between the x-intercepts is going to be the actual minimum point. I'm not sure. That's not an official math statement, but the middle point will definitely give you a sense, the best sense for how far that turning point dips or peaks. So, okay, let's do this. So x cubed minus 5 times x squared. Store that as e. So now you want to do e with x is equal to, let's see, so let's do 2.5 minus 15.625. So that's 5 halves minus 15 and 0.65, that's 5/8. Okay, so we've got f of 1, f of minus 1. So now let's do f of 6. $36. So this will be good. You can do more points if you want, but I find this is helpful because, when you're going off to, so as x approaches infinity, the function goes to infinity, you might do something like this, right? And then you go, that seems reasonable, but we can see this is x is equal to 6, and the function value is 36, whereas like f of 1 and f of minus 1 are minus 4 and minus 6. So this is going to be pretty steep. We want to make this pretty steep. So, okay. Let's see. Let's go to minus 20 and then 20. So at this halfway point, 1, 2, 3, 4, 5, minus 15.625. So each of these is 2. 2, 4, 6, 8, 10, 12, 14, 16. So like right there. Okay, f of 1 is minus 4. 2, 4. And then f of minus 1 is minus 6. 2, 4, 6. Okay, and so you see f of 6 is 36. You don't want to do this. That's not right, because this is coming 30, at this point is all the way up here. So, okay. And again, I don't know if it's the case that the middle between two x-intercepts, when you have a turning point, that the middle is going to be the peak or the trough of the turning point, but for the purposes of a rough sketch, we can do it that way if it makes it easier to draw. But okay, so we can actually, let's do this first. So it's going to touch the graph here and then do like that, and then this will, could do that. Yeah, I probably could have drawn this a little steeper, but that's good. So let's go through this and see if everything adds up. We've got the y-intercept correct, and it's also the x-intercept with even multiplicity, so it just touches the graph here. We've got this x-intercept. It's a cross through. We've got, let's see, we plotted some points, and the graph passes through those points. As x goes to negative infinity, the function goes to negative infinity. As x goes to positive infinity, the function goes to positive infinity. Okay, and let's see, we've got one turning point. Again, we don't consider this a turning point. And the degree of the polynomial is 3. So what that tells us that the maximum number of turning points is going to be 2. But we've only got 1, that's fine. We just can't have more than 2. If we have more than 2, then we know we did something wrong. So there we go. Okay, so usually we would start by factoring the polynomial expression, but this one's already factored. And now we can see that there's going to be zeros at 2, -1, and -3. And they all have multiplicity of 1. All right. We've got, so let's see, what's the y-intercept going to be? So 1/2 times -2 times 1 times 3. 3 times -2 is -6. -6 divided by 2 is -3. So the y-intercept is -3. Okay, the end of behavior. So the leading term is going to be x times x times x times 1/2. So 1/2 x cubed. So as x approaches infinity, this function it's a positive coefficient, and x to an odd power. This is going to go to infinity. And then as x approaches negative infinity, the function is going to go to negative infinity. Okay, so let's go ahead and plot the x-intercepts and the y-intercept. So we'll do, okay, so, well, we can check. This isn't going to be an even or an odd function. Let's see, f of minus x is, so, okay, this is minus x. You could take out a minus, you get x plus 2. So let's see. You took out a minus. There's a minus here. You take out a minus. You make this a minus x. But you take out a minus, you get x minus 1. Then you make this x a minus. You take out a minus, you get x minus 3. And now, so this have a minus. But okay, is that like if you distributed that minus now? Yeah, no. This is not going to be an even or an odd function. Okay, so let's see. X is equal to 2. 1, 2, 3, 4. 1, 2, 3, 4. Okay, x is equal to minus 1. 1, 2, 3, 4. And minus 3. 1, 2, 3, 4. 1, 2, 3, 4. Okay. Now we can, let's do, so 1/2 times x minus 2 times x plus 1 times x plus 3. Store that as e. Okay. So e with x is equal to 0 should be minus 3. That's right. Okay. Now, e with, let's get a point to the, all the way to the right of the farthest x-intercept to the right. So that's, let's get x is equal to 3. We get 12. So f of 3 is equal to 12. Let's get f of maybe minus 4. Minus 9. Okay, let's get in between these two. So f of minus 2 is 2. Okay, and let's get halfway between these two. So this is 2, this is minus 1, so that's 1/2. So f of 1/2 is what? Minus 63 over 16 minus 3.94. F of 1/2. Okay, so that gives us a sense for how big to make this scale here. And we can do, so we don't need to plot the points that are away, that are off in the infinity area. We don't need to actually plot those. And I would say let's not plot those so we can get a better visual on the actual shape of the graph in the middle regions. We just need these ones like f of 3 just to give us a sense for how steep to make it at the ends. That's it. So let's just go from 5 to minus 5. So, okay, f of minus 2 is 2. So 1/2, 1. So here, okay, f of 1/2 is about minus 3.94. 1/2, 1. 1/2, 2, 2.5, 3, 3.5, 4. So about, pretty much on right there. Okay, the y-intercept 1/2, 1, 1/2, 2, 2.5, 3 is here, and there we go. So, okay, now I'll make these midpoints between the x-intercepts. I'll make those the minimum points. Again, I'm not sure if that's an official. That's officially always the case, but for these rough sketches, it's fine. Well, okay, wait. So as x goes to infinity, let's see. This goes to positive infinity as x goes to infinity, but f of 3 is 12, and so yeah, you can see it's going to be that f of 3 is where? 1, 2, 3, 4. I mean, it's not that steep, I guess. So there we go, something like that. And then f of minus 4 is minus 9. That would be 1, 2, 3, 4. So it's not that steep. Maybe like that. And there we go, something like that. So let's check to see if we've got everything. As x goes to negative infinity, the function goes to negative infinity. As x goes to positive infinity, the function goes to positive infinity. You've got 3 x-intercepts. They're all odd multiplicity, so just cross over. That's right. We've got the y-intercept correct. We've gone through the extra points we've plotted. And then there's 2 turning points. And this is a cubic, and this is a function of degree 3. So the maximum number of turning points is 2, so we're fine there. So yeah, there we go. Let's start off by factoring the expression. So let's take out an x squared. Okay. So let's see. Plus 4 minus 2 is positive 2. Plus 4 times minus 2 is minus 8. So there we go. X squared, x plus 4, x minus 2. Okay. So we've got, let's see, the y-intercept is at the origin. Okay. Let's see, as x goes to infinity, the function goes to, so we check the x to the 4th, it's going to go to infinity. It's x to the even power with a positive coefficient. as x goes to negative infinity, it's also going to go to positive infinity, the function. Okay? So let's see. Let's plot the x-intercepts. So x is equal to 2, 2, 3, 4, 1, 2, 3, 4. X is equal to minus 4, 1, 2, 3. So let's see. Okay, now, again, I mean, technically we have all the information we need to plot, to get a general plot of the function. So some people will plot it from here as, let's see, this is as these two x-intercepts at the end are odd multiplicity, so they cross the x-axis. As x goes to infinity, the function goes to infinity. So we're going to have to have a turning point here, and then to get to, this is going to be, we're going to bounce off of the graph here. So, okay, and then we're going to, as x goes to negative infinity, the function also goes to infinity. So now this is just going to be a bigger dip because of, there's a bigger gap here. And there you go. There's the general shape. But we're going to go ahead and plot some extra points. So, okay, let's do f of 1. Or no, this is k. Yeah, we're doing k. Okay, so k of 1 is equal to 1 plus 2 minus 8. 3 minus 8 is minus 5. All right. Now let's do k of minus 2. So we can go halfway between these two. So minus 2 to the 4th is 16. Minus 2 cubed is 8. 8 times 2 is, okay, so this would be minus 16. And then minus 2 squared is 4. 8 times 4 is 32, so minus 32. So that'll give us a sense for how far to dip down here. Okay, now let's do, so, okay, x to the 4th plus 2 times x cubed minus 8 times x squared. Store that as e. So e with x is equal to, let's go to 3, 63. So k of 3 is 63, and let's do k of minus 5. $175. Okay. That'll just help us with how steep to make the ends. But again, we're not plotting these points that help us draw the end point behavior, the end line behavior. So, okay, k of minus 2, though, we are going to go through this point. So we'll make this go from minus 40 to 40. So each of these tick marks is 4. Yeah. So, okay, let's do minus 2, 1, 2, 3, 4, 1, 2, 3, 4. 8 times 4 is 32, so 1, 2, 3, 4, 5, 6, 7, 8. Okay. K of 1 is 1, 2, 3, 4, minus 5. So this is minus 4, so just a little bit past. Okay. And then, so k of 3 is 63. Here is 1, 2, 3, 4. So yeah, I mean, this helps you with, because this is an example of where it's really helpful to get the endpoint, to get an endpoint like this, because it's hard to see, you know, this is going to be pretty shallow, but then, you know, if you do like this, right? Well, no, because 1, 2, 3, 4, k, this is k of 3. That's going to be at 63. So we need to be like this, right? And so this is an odd multiplicity x-intercept. We're crossing through here. And, okay, well, this is even multiplicity, so we're... Yeah, you know, I didn't... It seems like this, it might not be, the middle point might not be the minimum point. It just depends. So, all right, so x goes to negative infinity. Let's see. Negative 5, 175. So this is going to be pretty steep too. So there we go, something like that. So as x goes to positive and negative infinity, the function goes to infinity. We go through we go through the points that we plotted here in the middle of the function. We've got 3x intercepts, 2 crossing intercepts, that's right, one that kisses the graph. Then we got the y-intercept correct, and then we've got 2 turning points with a degree polynomial 4, so that checks out. So there you go. Okay, let's start by factoring this. So we want to take out an x squared, 9x cubed plus 9x squared minus 25x minus 25. Okay, now we've got a 4-term expression. Anytime we have an expression with 4 or more terms, we want to start by thinking about grouping. And it looks like the right terms are already paired together, so let's take out a 9x squared from these 2 terms and a minus 25 from these 2 terms. Okay, yes, the grouping worked. Now we can factor out an x plus 1. Okay, now we have a difference of 2 squares here, so we can turn this into 3x minus 5 and 3x plus 5. Okay, so we've got x squared times x plus 1, 3x minus 5, 3x plus 5. Okay, so the y-intercept, we plug in x is equal to 0. Is that 0? Okay, so we can plot, let's see. So let's plot the y-intercept. Okay, so we can see we've got x-intercepts, or the zeros, are at x is equal to 0 with multiplicity 2, and then x is equal to minus 1, 5/3, and minus 5/3, all with multiplicity 1. So what is 5/3? 1.7. Okay, so let's plot these. 1, 2, 3, 4. There's minus 1. 1, 2, 3, 4. 1.25, 1.5, 1.75. So around right there. 1.25, 1.5. So around right there. Okay. Now, does this function have any symmetry? So minus 9x to the 5th plus 9x to the 4th plus 25x cubed minus 25x squared. Well, that's not the original function, but if we took out a minus sign, we get 9x to the 5th minus 9x to the 4th. So no, it's not even or odd, and it's not periodic. So there's no symmetry here. Okay, as x goes to infinity, the function goes to what? We're going to look at the first term. Positive coefficient, x to an odd power, so this is going to go to infinity. And then as x goes to infinity, okay, And so, just again to point out, this is enough to sketch. We know the general shape of the graph, because we can say as x goes to infinity, the function goes to positive infinity. We cross through here. We're going to be kissing the graph here, a touch point. So we'll be coming down, have to come back up. As x goes to negative infinity, the function goes to negative infinity. So yeah, it's going to look something like this. This is the general shape. Okay, so, and again, some people are fine with this. They draw this neatly like shown here, and they're fine with that. And you could if you want to go faster, you could do it, just sketch this. But we're going to go a little bit farther and get some points. So, okay, let's see. Let's do, and again, you can plug in the easiest points that you can. So like you might say, let's just plug in, this is, just plug in P of 1. And that's fine. So you get 9 plus 9 is 18 minus 25 minus 25. So 18 minus 50 is minus 32. And you can stop there, right? But the problem is, what I found is that you want to get the midpoints between the x-intercepts, because that gives you the best sense of how far the turning point's going to go. And again, it doesn't mean I'm not, and again, that's not definitely the lowest point is the midpoint, but I think that gives you the best sense of it. It's close. I think that's the closest. If you're just going to guess what the minimum point's going to be or the maximum point, you want to just go ahead and put the midpoint of the interval. Okay, so like, yeah, minus 32, but I mean, how much, perhaps this dip goes further than minus 32. So how much further, right? How far do we make this axis go down? So let's plug in. This goes to, let's see, we just plugged in P of 1. I mean, that's pretty good, because this is at 1.67. This is 1.67. We went to 0.25, 0.5, 1. Yeah, so we just went here. I mean, that's pretty close to the midpoint, so I'm fine with that. So, okay, that's good. Now, let's plug in here. Let's do P of minus 1/2. Okay, 9 times x to the 5th. Okay, so there's the equation with x is equal to minus 1/2 minus 91 over 32 minus 2.84. So this is minus 2.84. Now let's do something between these two. We could do minus 1 1/4. So f of minus 5/4. $4.27. Okay, now let's do the away from the endpoints. So f of here, let's do f of 2. $132. And then let's do f of minus 2. Minus 44. Okay, so let's make this go to minus 40. Okay, so let's plot f of 1 is minus 32. So 1, 2, 3, 4. So 1, 2, 3, 4, 5, 6, 7, 8. Okay. And then f of minus 1/2 is minus 2.84. So this is minus 4, minus 2. So like right there. Then minus 5/4 is minus 1 1/4, 4.27. Okay, and then let's see. At 2, so let's see, 1, 2, 3, 4, 1, 2, 3, 4. So here it's 132. So you see it's steep. You know, that's even, I didn't draw that steep enough because it's got to go, when it gets to the vertical line here, it has to be at 132. So like that. And then let's see, here we've got f of minus 2. It's here, minus 44, not quite as steep, but still pretty steep. Okay. There we go, like that. As x approaches negative infinity, the function approaches negative infinity. As x approaches, this is negative infinity. As x approaches positive infinity, the function approaches positive infinity. You've got 3 turning points in a 5th order equation. So the max is 4 turning points. We've only got 3. You got 1, 2, 3, 4 x-intercepts with 3 having odd multiplicity and 1 having even. And so, yeah, there we go. Okay. Let's factor this. We'll start by saying u is equal to x squared, which means this is minus u squared plus 11u minus 28. Okay, now let's take out a minus 1. All right, so now we can factor this. 7 times 4 is 28, and 7 plus 4 is 11. Minus 7 minus 4 is minus 11. Minus 7 times minus 4 is positive 28. So now substitute the u back in. Okay, difference of 2 squares. Okay. And there we go. So this is minus x plus root 7 okay. Now let's see. T of the y-intercept, t of 0 is, we can see, is minus 28. Okay, now what is root 7? 2.65. So, okay. Let's do 5 to minus 5. We've got x. Okay, so 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And then, well, okay, if we check for symmetry, this looks like it could be an even function. So t of minus x is minus x to the 4th plus 11x squared minus 28, which is equal to t of x. So this is an even function. So, okay, that means that it's symmetric about the y-axis. So, all right, root 7 is 2.65. So 0.25, 0.5, 0.7, so about right in here. 0.25, 0.5, so about right there. Okay. Now, let's look at the endpoints. As x approaches infinity, f of x approaches x to the even power with a negative coefficient. So this is going to be negative infinity, and then as x approaches negative infinity, that will also be, f of x will also go to negative infinity. Okay, and so this is enough to, we could just do a rough sketch here. So we've got, let's see, going to negative infinity, and then we would do, and then it's going to be symmetric. So this will have to be like the bottom point. The graph's going to look something like that. Okay, so we can plot the y-intercept. Let's do, so, okay. 3, 6, 9, 12, 15, 18, 21, 24, 27. So there's 28. Okay, now let's plot, just to get a sense for how high it goes. Let's plot. So, okay, we've got minus x to the fourth plus 11x squared minus 28. Okay, now e with x is equal to, let's just say 2.25, 2.06. So t of 2.25 is approximately 2.06. So here is 2 1/4. So we go about right there. That's 2. Okay. Now, to get a sense for how steep, we can do just x is equal to 3 minus 10. So t of 3 is minus 10, and we can actually plot these. So, okay. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Right there. Okay, so let's see. Okay, like that. As x goes to positive and negative infinity, the function goes to negative infinity. We've got 3 turnaround points with x to the with a 4th degree polynomial. So we have the maximum number of turnaround points. 4 x-intercepts, all of odd degree multiplicity. So we were good there. And then we got the y-intercept right. So there we go. Okay, last problem. We've got, it's already factored. We've got 3 x-intercepts, 3 zeros, all with odd multiplicity. But we got 3, minus 3, and minus 1. Looks like this is not going to have any symmetry. Okay, the leading term is going to be x cubed times x. That's so minus 1/10 x to the 5th is going to be the leading term. So as x approaches infinity, the function is going to approach negative infinity. As x approaches negative infinity, the function is going to approach positive infinity. Okay, now the y-intercept minus 1/10 times 3 times minus 3 times 1. So it's going to be 9/10. Okay, let's go ahead and plot the x-intercepts. So we've got, so okay, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Okay, so we have the endpoint behavior and the x-intercepts in their multiplicity. So we know the curve is going to look something like, as x goes to infinity, this goes to negative infinity, positive infinity. We don't have any, all of the intercepts are crossing intercepts, so it's going to look something like that. That's going to be the general shape. With that cross, the y-intercept is going to be 9/10, the crossover point up here. So now let's do this. Minus 1/10. Okay. Now let's plug in a point halfway between -1 and 3, so which would be at like 1. So e with x equal to 1 is 32/5. 6.4. So m of 1. Okay, now what about m of -2? -1/2. It's equal to -1/2. Okay, now what about, let's see, m of 4 and m of -4? Minus 87.5 and 18.9. Okay, so now this m of -2 here is pretty small, so let's, we're going to need to incorporate this 6.4 though. So let's do -8 to 8. So each tick is 0.8. Okay, so 1, 2, 3, 4. Let's see, 6.4 divided by 0.8. How many ticks is that? 8 ticks. So, okay. All the way up here. All right, now m of -2 is -1/2. So this is 0.8 minus 0.4 right there. Okay, now this 9/10 is right below, or no, right above, sorry. This is 0.8, so it's going to be right above. Okay, so let's see. We can, okay, actually, just curious, what is, let's plug in 2, see what we get. 27 halves, 13.5. So f of 2 is off the graph. So, okay, didn't draw enough points. Something like that, which makes sense because this is going to be pretty steep coming down, right? And then like that. As x goes to negative infinity, the function goes to positive infinity. As x goes to positive infinity, the function goes to negative infinity. You've got 2 turning points with the degree 5 polynomial. All the x-intercepts are crossover intercepts, and with got the y-intercept plotted, so there we go.